Welcome back to the morning show. We are talking baseball, appropriately enough, since we are in World Series time. The Wise Guys here talk about the sweet spot and how they are hitting those home runs. And we have a lot to talk about this morning.
Goodness.
As we talk about on this show a lot, I'm a Cardinal fan, so I was not very happy to hear that they were. Now, I'm rooting for the White Sox and everything, but I was upset that they were opening the roof of the Houston because they say that the weather and everything kind of affects the ability to make a home run. So tell me about it.
Well, I don't know about that. All I can say is it's open for both teams. So
or closed for both teams.
It's not giving anybody a big advantage, I would think.
Okay.
And I don't think the changes in humidity and temperature and all that are really significant. I mean, the big deal about hitting the ball far is getting bat speed and hitting it just right and getting it over that wall.
It's not the wind or the...
Well, usually there isn't much wind.
But, okay, so you have a scientific formula here.
Oh, I have all kinds of stuff. In fact, it turns out that in my department, there's a professor, Al Nathan, who is the world's expert on the physics of baseball, or one of them. And so we sat and we talked about this for quite a long time. And he gave me all kinds of good notes, and he made some calculations for me about what really happens. Because what we talk about usually in physics is we say, you ignore air resistance, you make all these assumptions which are not true at all in baseball. So the important thing in baseball is, let's say, to hit a home run. Okay, so let's see, what does it take to hit a home run? And down at the Astrodome or Minute Maid Park or whatever it is these days, okay, if you look, left center field is about 362 feet away from the plate. But it's a high wall. It's about 25 feet high. In U.S. Cellular Field, it's about 377 feet. It's a little farther, but it's a lower wall. Okay. So if you work it out, it turns out that the way you have to hit it to get a home run at left center in either one of those parks is about exactly the same. Okay. Okay, because in one case it's farther, but it's lower. It's closer, but it's higher, and it works out about the same.
Interesting. All right.
And so what Al worked out for me, and what seems perfectly plausible, is that what you have to do is you have to get the ball going about, you have to get about 91 mile an hour speed on the ball after it's hit. Okay?
After it's hit.
After it's hit. And the key component is that you want to hit it about 30 degrees above horizontal. The ball has to be going about 91 miles an hour, and it has to have about 2,000 RPM of backspin on it. All these things are very important. Okay?
And this is to hit a home run?
This is to get it to go just over the wall to get a home run at left center field in either park.
Okay.
Okay? And so
how does it matter how fast they're coming at you? Because that's, when you're watching the game, that's what you hear is the speed, whether it's 70 or 80, 90, whatever miles per hour.
Right. So the way that you get the ball going about 90 miles an hour or 91 miles an hour is that you need a bat speed of about 60 miles an hour. Okay, and a pitch speed of about 90 miles an hour.
Okay, and then that'll make it work.
And that'll make it go over, that'll just squeak it over the wall.
If you've got the perfect pitch and backspin and everything else.
The important part is really the bat speed.
Okay.
For every mile an hour of speed you can get on your bat, in addition to what I just said, the ball will go about 7 feet farther.
Okay.
Whereas for every mile an hour faster than that the ball is pitched, it's going to only go about maybe 1 foot farther.
Oh, okay.
But the spin is also very important. So it turns out that if you manage to hit it in such a way that the ball's not spinning at all, then instead of going, it's going to go about 50 feet less.
Okay.
It makes a huge difference.
It's just going to pop up and they're going to get you out.
Well, it's not going to go as far as you want it to go.
Yeah.
Okay. And so the key is the spin, it's the bat speed, and everything else. And just to compare, if there was no air whatsoever and you were to hit it at the same angle, the ball would go 100 feet farther. I mean, so the air really does make the thing slow down somewhat. Okay? And it's kind of like in golf. I don't know if you remember, but we talked about golf a few weeks ago.
We did.
What the spin does is it gives the ball a little bit of lift as it goes through the air. So instead of hitting it at 45 degrees, which is what you would do to get it really to go far if there was no air, it wouldn't work at all, then you hit it a bit lower, but the spinning ball gives it some lift, and so it leaves at about a 30-degree angle, and then as it comes down to the ground at the other end, it's coming down at about a 45-degree angle.
Okay, so we've talked about angles, we've talked about speed and all of that. In the next segment, we're going to talk about the so-called sweet spot.
Yes. So the very important component about getting all of this to work is that you hit the ball on the right part of the bat. If you don't hit it on the right part of the bat, none of this is going to work at all the way I said.
Do the White Sox know we're talking about this today? Have you been consulting with them?
I think they know a little more about baseball than I do. So anyways, and it's probably,
all right.
And I don't think it's good to think too much about this stuff either when you're hitting.
Yeah, you just want to swing for it. All right, well, we're going to talk about that sweet spot, and we have some video coming up to show you from one of the world's leading experts on the physics of baseball. Yes. But for now, our wise guy, Matt, thanks for being here this morning. We appreciate it.
Oh, having fun.